Let's look at what the transfer price will look like when the central HQ is making the decisions versus when the selling unit is making the decision. So suppose General Motors, GM, makes and sells several car brands, including Chevy and Buick. Chevy supplies the engines that go into Buick cars. That is, Chevy builds engines and can sell them internally to Buick, who builds and sells cars. So just to simplify our example, we're going to say Chevy does not build cars, they only build engines, so they are the selling unit. And Buick is the buying unit. Chevy's variable cost to build each engine is $1. So that's the variable cost per unit. On Buick's side, suppose that in addition to the transfer price that Buick pays Chevy for each engine, Buick incurs an additional $2 to build each car. So this is the variable cost coming from Buick. Finally, suppose that the market demand for Buicks is given by the equation P equals 10 minus Q over 16, where P is the sales price per car and Q is the quantity of Buicks sold. Notice that this equation indicates price and quantity are inversely related. So the sales price per car decreases as the quantity sold increases and vice versa. If you think of it very intuitively, if the sales price of the car is really low, then more Buicks will be sold. If each Buick is very expensive, less of the Buicks would be sold. So to tackle this issue, we first have to recap some of the things that we learned in our econ and calculus classes, starting with our econ class. So you may remember that profits are maximized when marginal revenue equals marginal cost. What's marginal revenue? Well, marginal revenue is the additional revenue generated by increasing the quantity of a product sold by 1 unit. So every time you sell 1 unit, what's my additional revenue that I earn? In mathematical terms, marginal revenue will be equal to the derivative of the total revenue function with respect to total quantity sold. Marginal cost is the additional cost generated by increasing the quantity of a product sold by 1 unit. And in mathematical terms, marginal cost would equal the derivative of the total cost function with respect to total quantity sold. So now we have to kind of recap what derivatives are. And you don't really have to know a lot for this class, just the basics of calculus. If you want to take the first derivative of x of n, then it simply is going to be n times x of n minus 1. So what you do is you pull down this term here and you deduct minus 1. So if we want to take the first derivative in terms of x of this function, then we do it for each component independently. The first one, we pull down the n, and then it's x of n minus 1 plus, we have 3, and we're going to pull down the n minus 1 and deduct minus 1 from above. So x to the power of n minus 2. And then the final term, 3 of n, it has no x term. So when we take the first derivative of 3 of n with respect to x, that's just going to be minus 0. So that will be n x of n minus 1 plus 3 times n minus 1 times x to the power of n minus 2. So remembering this, now we can get into solving the problem. Starting with the centralized situation. Suppose GM adopts a centralized transfer pricing policy and sets the transfer price at $1, which is equal to the Chevy's variable cost to build each machine. What would be GM's profit, and how would those profits get split between Buick and Chevy? So here we are in a situation where we're in a centralized world, and GM sets the transfer price. And they decided to set it at $1. Now, as GM is a for-profit firm, GM would want to maximize their own profit. And they know that they will be able to maximize their profit where their marginal revenue equals marginal cost. So marginal revenue is the first derivative of the total revenue function in terms of Q. So let's find what the total revenue function looks like. So total revenue is just equal to the selling price times quantities sold. And I'm just going to say this is P times Q. Now we know what P is equal to from the demand function here. P is equal to 10 minus Q over 16. So let's plug that in. 10 minus Q over 16 in place of P times Q. So now we have a total revenue function that is just explained in terms of Q. So it's 10Q minus Q squared divided by 16. So now we can find marginal revenue by taking the first derivative of the total revenue function with respect to Q. So that's 10Q of 1 minus Q squared over 16. And we're taking the derivative of this. This signal here is just saying that I'm taking the derivative. So like I did before, we're going to pull down whatever is on top of the Q. So that's 10 times 1. And then deduct 1. Next, we go to the second term here. We pull down the square. And then we deduct 1 from Q's power. So that would equal 10, because Q to the power of 0 is 1, minus this raises itself, Q over 8. So that is our marginal revenue function. Now let's find the total revenue function to find the marginal cost. Total cost is equal to the variable cost of Chevy plus the variable cost of Buick times the quantity sold. We know that the variable cost per unit for Chevy is $1. The variable cost per unit for Buick is 2 times Q. That's our total cost function. That's 3Q. And now we have to take the first derivative of the total cost function to find marginal cost. And if we take the first derivative in terms of Q, that would be 3. So now we can find the quantity sold that will maximize our profit by finding the point where marginal revenue equals marginal cost. We just have to plug in what we just found here. Marginal revenue was 10 minus Q over 8. And marginal cost was 3. If we move things around, we find that the quantity that maximizes our profit is 56 cars. And now we can find the price at which our profit will be maximized by plugging this quantity into our demand function here. That's 10 minus 56 over 16. And that would be $6.5. So GM can maximize their profit when they sell their cars at $6.5 and sell 56 of them. So now let's look at what the profit would look like, given the number of cars that we'll be selling and the selling price. Starting with Buick. So Buick is the one that buys the engine from Chevy and sells it to the market. And the market price would be set at $6.5. So Buick would get $6.5 for each car, but they have to pay the transfer price to Chevy for the engine, and they have their own variable cost per unit. They'll be selling 56 cars. So 6.5 is the selling price. We know that GM set the transfer price at $1, and Buick's variable cost per unit was $2. So if we multiply that by 56, we find that Buick's profit will be equal to $196. Now let's look at Chevy's profit. So Chevy will sell their engines to Buick at the transfer price, and their variable cost per unit is $1, and they'll be selling 56 cars. The transfer price was set at $1, and their variable cost per unit is again $1. So Chevy's profit will be $0. And GM's profit, which is the parent company of both Buick and Chevy, will just be the sum of Buick's profit and Chevy's profit. So it would be $196. So this is what the company's profit would look like when GM is setting the transfer price. Buick will take all of the profits, and Chevy will walk home with no profits at all. Now let's look at a situation where Chevy determines what the transfer price is. So this requires a few steps for us because Chevy will want to set a transfer price that will maximize their profit. And given that transfer price, Buick would want to buy the number of engines that would maximize their own profit. So for now, we're just going to say that Chevy set the transfer price at an unknown number, and we're just going to name it TP. Now, Buick has to find the quantity and selling price that maximizes their total profit given Chevy's transfer price. So that goes back to finding Buick's point, the point where Buick's marginal revenue equals marginal cost. So we're going to start with the total revenue for Buick, which is P times quantity sold. Again, oh, where did I go? Again, we just have to plug in 10 minus Q over 16 in the place of P. Times Q. So our total revenue function is still 10Q minus Q squared over 16. So our marginal revenue function will still be the same because we're still taking the first derivative of Q. It will be 10 minus Q over 8. And now let's look at our total cost for Buick. So the total cost for Buick will be the transfer price plus the variable cost per unit times quantity sold. And we don't know the transfer price yet, so we just decided to use TP. And the variable cost of Buick is $2. And then we multiply that by Q. So the marginal cost, if we take the first derivative of the total cost function with respect to Q, is TP plus 2. So Buick can maximize their profit when their marginal revenue equals marginal cost. That's when 10 minus Q over 8 equals TP plus 2. And this helps us define Q with respect to TP. How? We shift around the numbers and we know that the optimal quantity for Buick would be 64 minus 8 TP. So this means a higher transfer price would lead to Buick producing less cars or buying fewer engines from Chevy. So again, we're trying to find what the transfer price would look like if Chevy is setting the transfer price, but because we do not know that, we're first going to find what Buick would do when a certain transfer price is given. We're going to use this number to figure out what transfer price Chevy will set. So now that we have the quantity that Buick will order based on the transfer price that Chevy sets, now we can look at what Chevy will do and what transfer price Chevy will set. So here, Q equals 64 minus 8 TP. So this is how many engines Buick will order given the transfer price. And now with this information, Chevy can find the point which maximizes their profit. So let's find the total revenue function for Chevy. Their price is the transfer price. And their total revenue would be transfer price times the quantity sold. We already know how to write Q in terms of for the transfer price because we have that function over there. So we plug that in, TP times 64 minus 8 TP. That would be 64 TP minus 8 TP squared. Now let's find the marginal revenue of Chevy with respect to TP, not Q. So that would be 64 TP minus 8 TP squared. And we're taking the first derivative in terms of TP. The first term is 64 because it's TP to the power of 1. And then minus 16 times TP. So this is our marginal revenue. Now what's our total cost function for Chevy? Well, the variable cost for Chevy is just $1. And they're going to sell Q amount of cars. So the total cost is 1 times Q. We are going to replace Q with our function up here. So that would be 64 minus 8 TP. And now our marginal cost with respect to TP would be equal to minus 8. Because there's only 1 TP in the total cost function. So now let's find the point where marginal revenue equals marginal cost for Chevy because we want to maximize Chevy's profit. So that's 64 minus 16 TP is the marginal revenue function. Minus 8 is the marginal cost. We move these around. We find that Chevy will be able to maximize their profit when they set their transfer price at $4.5. So now we know what the transfer price is. And now we can find the profit of GM and the profit of Buick and Chevy as well. How? Let's do this in the next slide. So if we go back to Buick, we know that the quantity that helps them maximize their profit was when 64 minus 8 TP equals quantity. We know what the transfer price is now, so we just have to plug that in. 64 minus 8 times $4.5. So that is 28. So Buick will be able to maximize their profit given a transfer price of $4.5 when they sell 28 cars. And now that we know the quantity, we can find the price at which Buick will be selling these cars by using the original demand function of Buick cars, which was 10 minus Q over 16. Now we know the Q, that's 28 over 16. So Buick will be selling their cars at $8.25. So with that, Buick's profit would be equal to the selling price minus the transfer price minus the variable cost times quantity sold. We know that they're going to sell their cars at $8.25. The transfer price would be $4.5. The variable cost per unit for Buicks was $2, and we're going to sell 28 cars. We do that, we find that Buick's profit would be $49. What about Chevy? Chevy's profit. Well, Chevy's selling price is the transfer price, $4.5, and their variable cost per unit was $1, and they will be selling 28 engines to Buick. So Chevy's profit would be $98. Now GM's profit, the parent company, will just be the sum of Buick's profit plus Chevy's profit so $49 plus $98. So GM's total profit in a decentralized organization where Chevy is setting the transfer price would be $147, which is lower than GM's profit when GM was the one setting the transfer price. So if we compare the answers from what we got from a centralized organization to the decentralized organization that we just did now, we find that under a decentralized organization, Buick's profit goes down, Chevy's profit goes up, but at the net level, at the firm level, GM's profit also goes down. So what's happening? Well, the lower overall profit is the product of a coordination problem. So here, we let Chevy decide the transfer price, and Chevy was making a decision based on what would maximize their own profit. But the problem is that what's best for Chevy was not what was best for GM. So decentralizing transfer prices might have some unintended consequences where the firm's overall profit goes down because each division have their own incentives, and that might not necessarily lead to profit maximization at the firm level. This was a really difficult concept to go through. I highly encourage you to go through this video several times to understand the concept. If it's difficult, please come to my office hours so that I can go through it with you in more detail. All right, in the last video, we will learn how transfer prices can be used to lower taxes for multinational or multi-jurisdictional companies.